So a kid is standing on the top of a set of football bleachers at one of the football games and decides that they're going to drop water balloons on the people below them. So when I look at this, maybe they are standing up here. Once I draw this here, so here's the bleachers. They stand up here on top of the bleachers and they have water balloons that they're going to drop down, trying to hit people down here on the ground. So what are my givens? What do I know in this case? Well, I know that the height that the balloon is going to fall is 10 meters. Notice that because the balloon is going down, don't forget that we have to make that be negative because that is a displacement, not a distance. We also know because this is going down that the acceleration of gravity is negative 9.8 meters per second squared. And the last thing that we know is that since the student or the kid is dropping the water balloons, we know that the initial velocity at the top of that has got to be, or we're going to have to assume that it is initial velocity of 0. Then part A, we're asked to find the final velocity just before it hits the ground. So I'm looking for the final velocity here. What equation has these 4 variables, or which one does not have time in it? You guessed it, it's going to be the squared one. So VF squared equals VI squared plus 2AY. It could be X, but I use a Y because we're going up and down. And we can say that our final velocity is what we're looking for. So VF squared. Our initial velocity was 0. 2 times a negative 9.8 times a Y displacement of a negative 10. And when I multiply all of those together, I get a negative 196 is equal to VF squared. I'm sorry, not a negative 196. The two negatives cancel out to become positive. But that does bring up a good point. If you forget to make the Y value negative here, you forget this would be a positive, that would be a negative. And when I go to square root this to get VF by itself, I would have a negative under the radical, which says, hey, something is wrong. You forgot to make something negative that should have been, and in this case, it's the displacement. So whenever I square root that, I'm going to get a final velocity of 14 meters per second squared once I square root that. Now, a couple things you should remember. Because this is a square root, then the answer comes out technically positive or negative, but we know that the balloon is falling, so we have to make the value negative because the balloon has a velocity going downward, not upward. Part B then is how long does it take the balloon to hit the ground? How long does it take until the balloon hits the ground? So in this case, we're looking for a time. Now we can do either one of the other two equations. We could either do x equals VIT plus 1/2 AT squared, or we could do VF equals VI plus AT. It's really up to you. So I'm going to pick the one that I think is going to be easier here, and that's going to be this one on the right side. So my final velocity is a negative 14. My initial velocity was 0, so it cancels out. And then A is negative 9.8 and T. And notice again that if I had forgotten to put the negative on my final velocity, I would divide by a negative 9.8 and get a negative time, which we know is not physically possible. So when I do put the negative there, the two negatives become positive. Divide 14 by 9.8, and we have a total time of 1.43 seconds. That's how long it would take for the water balloon to drop from the top of those 10-meter high bleachers.